So you want to own a battery gigafactory. The first thing you need is not lithium. It is not land. It is not even a factory. It is someone willing to buy billions of dollars worth of batteries from you. Because a gigafactory without a customer is just an enormous industrial building full of very expensive chemistry. A gigafactory is a battery plant operating at enormous scale, usually measured by how many gigawatt-hours of battery capacity it can produce each year. That can mean tens of millions of individual cells. The obvious market is electric vehicles, but batteries are also needed for grid storage, industrial equipment, electronics, commercial vehicles, and backup power. Before you build anything, you need to decide what kind of battery you are actually making. Lithium-ion is not one chemistry. Some batteries use nickel, manganese, and cobalt. Others use lithium iron phosphate, usually called LFP. Each chemistry has different costs, energy density, safety characteristics, charging behavior, and raw material requirements. Choose the right chemistry, and automakers may design entire vehicles around your cells. Choose the wrong one, and you may spend several billion dollars building a factory for a battery everyone has politely stopped ordering. And changing direction later is not simple. Your production equipment, suppliers, testing systems, and customer contracts may all be designed around one specific cell. So before construction begins, you are already making a bet on what the battery market will look like years from now. Then you need land, a lot of it. A gigafactory may occupy hundreds of acres once you include the production buildings, warehouses, utilities, parking, roads, loading areas, and room for future expansion. The site needs enormous electrical capacity, reliable water access or another cooling strategy, transportation infrastructure, and a large labor pool. Being close to automotive plants can also matter because batteries are heavy. Shipping thousands of battery packs across a continent is possible. It is simply an expensive way to discover geography. Then come the permits, environmental reviews, utility agreements, tax incentives, and government negotiations. Battery manufacturing has become strategically important, so governments regularly compete to attract factories with grants, loans, infrastructure support, and tax breaks. That is useful because your next problem is the price. A large battery plant can cost several billion dollars, and strangely enough, spending several billion dollars still does not guarantee that you know how to manufacture batteries profitably. That comes down to one number most people outside the industry never hear about: yield. And yield can decide whether your new factory becomes an industrial success or a very sophisticated machine for turning lithium into scrap. Inside the factory, battery manufacturing begins with powders, liquids, thin metal foils, and extremely precise machinery. Cathode and anode materials are mixed into slurries. Those mixtures are coated onto metal foil, dried, compressed, and cut. Then extremely thin layers are assembled into cells. Depending on the design, the finished cells may be cylindrical, pouch-shaped, or rectangular. They all share one important requirement: the layers inside must remain exactly where engineers intended them to be. If they do not, the battery may stop storing energy and begin releasing it considerably faster. Contamination is another problem. Some parts of battery production happen inside dry rooms, where humidity is kept extremely low, because moisture can damage the chemistry. Maintaining those conditions across a giant factory requires enormous air handling equipment running continuously. Then you need coating machines, ovens, cutting equipment, assembly lines, electrolyte filling systems, robots, testing stations, fire protection, laboratories, and automated material handling. The machinery alone can cost hundreds of millions of dollars. After a cell is assembled, it still is not finished. It must go through a process called formation. The cell is carefully charged and discharged so the internal chemistry develops correctly. That takes time, electricity, and more equipment. Then every cell has to be tested. Some fail. This is where yield becomes critical. Imagine your factory makes 1 million cells. If 95% pass inspection, your yield is 95%. That sounds excellent, until you realize the other 50,000 cells still used lithium, electricity, labor, machine time, and factory capacity. You paid to manufacture them. You just cannot sell them. At Gigafactory scale, improving yield by even a few percentage points can be worth enormous amounts of money. This is one reason new battery plants can struggle during ramp-up. The factory may technically be producing batteries while still losing money. Because too many cells are being rejected, machines are running below capacity, or workers are still learning the process. A busy factory and a profitable factory are not necessarily the same thing. Eventually, production improves, machines run faster, workers gain experience, defects decline, yield rises. And now you finally have millions of usable battery cells. Which brings us back to the problem from the beginning. Who is buying them? Ideally, you already know. Major battery factories are often built around long-term supply contracts with automakers. Those contracts can be so important that the customer may become your business partner. This is why battery plants are frequently joint ventures. An automaker brings demand. A battery company brings manufacturing expertise. Governments may bring incentives. Banks bring financing. Everyone brings lawyers. Then the factory gets built. The arrangement works because automakers do not want to discover 3 years into a new vehicle program that nobody remembered to secure enough batteries. But dependence on one large customer creates another risk. If that automaker cuts production, delays an electric vehicle program, or changes battery technology, your factory cannot simply decide to manufacture refrigerators instead. The equipment remains very specialized and very expensive. Once production is running, raw materials become your next obsession. A gigafactory may need enormous quantities of lithium, graphite, nickel, manganese, iron, phosphate, copper, aluminum, and other materials every year. Those materials may come from mines and processing plants spread across several continents, which is a polite way of saying your supply chain now has its own foreign policy. Prices can rise, governments can impose tariffs, mines can experience delays, refineries can become bottlenecks, and geopolitical disputes can suddenly turn one obscure mineral into the most important line on your supply spreadsheet. This is why battery companies increasingly care about the entire supply chain, not just the factory. If you cannot secure the materials, your billion-dollar production line becomes extremely good at standing still. Energy costs matter too. Dry rooms, ovens, cooling systems, compressors, pumps, formation equipment, robotics, and testing systems consume enormous amounts of electricity. You are building products designed to store energy using a factory that consumes quite a lot of it, which is either ironic or just Tuesday, depending on your electricity bill. Then there is safety. A gigafactory may contain huge quantities of flammable chemicals and millions of cells at different stages of production. Fire detection, ventilation, compartmentalization, emergency planning, and worker training are not optional details. A battery fire can be difficult to extinguish and expensive to explain. Scrap creates another opportunity. Defective cells and leftover electrode materials contain valuable metals that can potentially be recovered and recycled. Instead of treating production waste as garbage, manufacturers increasingly try to return those materials to the supply chain. When this works well, the factory becomes more efficient and less dependent on newly mined material. Eventually, the entire business comes down to a handful of numbers. What does each kilowatt-hour of battery capacity cost you to produce? How high is your yield? How much are your raw materials costing? How efficiently is the plant running? How much electricity are you consuming? And what is your customer paying? Tiny differences matter. If you save only a few dollars per kilowatt-hour across millions of cells, that improvement can become hundreds of millions of dollars. This is why scale matters so much. Gigafactories spread enormous fixed costs across enormous production volumes. But scale only works when there is demand. A factory capable of producing 40 gigawatt-hours every year sounds impressive. A factory producing 40 gigawatt-hours nobody ordered is a warehouse problem. And there is one more risk you cannot completely control: technology. Battery chemistry continues to evolve. Manufacturers are developing new versions of lithium-ion cells, solid-state batteries, sodium-ion batteries, and other technologies designed to reduce cost or improve performance. Your factory may take several years to build. The battery market does not promise to remain politely unchanged while you do it. That is why successful owners try to design plants that can evolve, upgrade equipment, change formats, and adjust chemistry over time. Could you realistically own a gigafactory? Not alone. You would likely need billions of dollars, experienced engineers, government support, utility agreements, global supply contracts, thousands of workers, and a major customer willing to commit years before the first battery leaves the line. A smaller battery business is much more achievable. You could buy cells from established manufacturers and assemble battery packs for commercial vehicles, industrial equipment, marine applications, or energy storage. But owning the full gigafactory means controlling one of the most capital-intensive manufacturing businesses in the world. You are betting on chemistry, electricity prices, mining, automation, government policy, vehicle demand, and technology all at the same time. And now we can finally close the question from the beginning. The first thing you need is not the factory, it is the customer. Because anyone with enough money can eventually build a building full of battery equipment. The difficult part is making sure millions of batteries have somewhere to go when the machines finally turn on.